Good morning, this is your Stat Sensei, Mr. Spensei, and this is the back to the harvest scenario that we were previously working with. The only difference is instead of doing a hypothesis test this time, we are going to conduct a confidence interval. So let's look at what we had originally. It says the Ministry of Agriculture is interested in examining possible changes in the time to harvest for sorghum. And past studies indicated that it was 100 days, and we had this data. Well, in our previous video, we rejected the null. So in this case, since we rejected the null, we think there is a difference. So we're going to go ahead and create a confidence interval for the true means. Also in the previous video, we didn't do the conditions for lack of space. Here we are going to. So our formula for confidence interval, x bar plus or minus t star s divided by the square root of n. So in this, I need to calculate t star stat test. Excuse me. Before we actually calculate, well, let's go ahead and calculate our t star stat. To do our calculator second vars, inverse t. So remember, t star is going to be an inverse t on the calculator. The very first thing it's going to ask for is the area. And the area we put in the calculator is 1 minus whatever the percentage is. So 1 minus 0.95. Divide that by 2. And our degrees of freedom, in this case, we had a sample size of 15. So our degrees of freedom is going to be 15 minus 1. So parenthesis 1 minus 0.95, close parenthesis, divided by 2, degrees of freedom, 15 minus 1. And we get a T star 2.1447. T star equals 2.1447. All right. The next thing, our X bar. Well, I can do that one of a couple ways. I can run the test all the way through, or I can do a stat test. I mean, stat calc one var stat. I'm going to do that real quickly. So there it is, X bar 107.666, and we had that earlier when we did our hypothesis test in the previous one. We have our standard deviation 8.1034. We have a sample size of 15, which means our degrees of freedom are 15 minus 1 or just 14. Now, I could have gotten that same information by going stat test and drop down to t interval. Data is in L1, change that confidence level to 0.95, calculate, and there it is, 107.66. There's my standard deviation. There's my sample size. Since I'm here, I'm going to go ahead and record my interval. 103.8, 103.18 to 1112.15. That's my lower. That's my upper. I can go ahead and draw my picture now. Confidence intervals, the pictures are centered on the sample mean. So they're centered on, in this case, 107.666, centered on X bar. We know that this area right here is going to be my lower, and this is going to be my upper. And if I take 1 minus 0.95 and divide it by 2, I find that this area right here is 0.025, and this area is 0.025. And we were just looking for these X values right here, this X and this X, which we got here. All right, so plugging into our formula, we need our X bar. Well, 107.6666 plus or minus T star 2.1447. Always make it positive. Standard deviation 8.1034. Divided by our sample size of 15, the square root of our sample size of 15. Inference procedures, well, we only had one sample, so we're going to tell them that it's one sample. What's our distribution? T, we did a T interval, that came straight off the calculator, and we're testing for means. All right, so our parameter of interest. We care about the population mean. We know the sample mean, we want to estimate the population mean. Let mu equal the true population mean time to harvest for sorghum. Mean time to harvest in days for sorghum. All right, so that's what we care about. Our conditions. Well, we have to have a random sample. So hopefully they did. What does it say? Random sample. All right. Random sample of 15 fields. And they told us that. So it's given. 2, we need to know, make sure that it's less than 10% of the population. So we're going to take N is 15, so 15 times 10, that's 150. All right. Well, they didn't tell us how many fields of sorghum there are, but we are assuming it's reasonable to assume that there are more than 150 fields of sorghums. Because there are probably thousands of them. It is reasonable to assume that there are at least 150 fields of sorghum. So what does that mean? N is less than 10% of the population. I'm going to run out of room, so I'm going to scoot this over here. All right. The next thing, normality. Well, they could have told us it was normal, but they didn't say that harvest time was normally distributed. Well, we don't, since we don't know, and our sample size is not 30 or more, we're going to have to test it. So we're going to have to enter our data and then draw a box plot of it and see, look for outliers and skewness. So second stat plot. First off, my data is in stat edit. And then I press the blue button followed by stat plot. Press enter. L1, because that's where my data is. I'm going to press zoom 9. And there's my box plot. It's a really nice box plot. And we can use the trace feature. But before I do anything, I draw it out. I try to make it kind of look like what's on the screen. I don't do this very well. Sure, most of you can draw better than I do. So there's my attempt at my box plot. And days to harvest is what our title is going to be. And I either have to put a scale on it or I have to label these things. So I'm going to use the trace feature and I find out that my minimum is 94. Min 94. Q1 102. Q3, 108. I mean, excuse me, not Q3, median, 108. Q3, 114. That's supposed to be a Q there. And then my maximum happens to be 122. All right. It's important to make the comment. The box plot is reasonably symmetric with no outliers. The data appears normal enough. Okay. Because we need normal enough data to proceed. All right. So now that we've done that, we need to do our conclusion. And our conclusion is basically going to be this. We are 95% confident that the true population mean, by the way, I'm just copying it from this, time to sorghum harvest in days lies within the interval 103.18 to 112.15. 103.18 to 112.15, lower and upper. All right, so that takes care of that. Then we need to define our confidence, what it means, the confidence level. What is that 95%? And what that means is in repeated sampling, we expect this method to capture the true population mean time to sorghum harvest 95% of the time. In other words, if we were to do this over and over and over and over again, on average, it would take 95% of the time we'd capture the true population mean time. 5% of the time, we won't. But 95% of the time, we're going to do it right. So that's how good our method is. All right. Appreciate you watching. Hope to see you on the next one. Thank you.